Let's take a look at this problem. We've got f of x is equal to the square root of 3x plus 2. And use the limit definition to find derivative of the function. So our first step, we want to find f of x. Well, f of x is given. So f of x is equal to the square root of 3x plus 2. Step 2, we want to find f of x plus h. And this is evaluating a function. So we'll go back to our original function, and wherever we have an x, we'll put in parentheses. So we got square root of 3 times parentheses plus 2. Whatever's inside the parentheses right here is automatically we're going to put in right here, which is x plus h. Do a little bit of simplifying. 3 times x is 3x, 3 times h is 3h, plus 2. Step 3. Plug it into our formula here. F prime is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. So plug in everything we found. F of x plus h from step 1 was the square root of 3x plus 3h plus 2 minus f of x, which was the from step 1, the square root of 3x plus 2 all over h. Now we want to find this limit. So we got limit as h goes to 0 of the square root of 3x plus 3h plus 2 minus square root of 3x plus 2 all over h times, and we'll use the conjugate method to find this. The radicals are up on top, so we're going to multiply top and bottom by the conjugate of the top. So this will be the square root of 3x plus 3h plus 2 plus the square root of 3x plus 2. Now what a conjugate is the first parts are the same. See how these square roots are the same? The last parts are the same. See how these are the same, but sign in the middle is different. See how this is a minus and this is a plus. Now whatever you multiply by the top, you have to multiply by the bottom. There we go. Okay. Well, up on top, nice part about multiplying conjugates together is all you have to do is multiply your first parts together and your last parts. So we've got square root of 3x plus 3h plus 2 times the square root of 3x plus 3h plus 2 minus square root of 3x plus 2 times the square root of 3x plus 2. Now the bottom part we won't actually multiply through, we'll just put them next to each other. So I got h times square root of 3x plus 3h plus 2 plus square root of 3x plus 2. So we got limit as h goes to 0. When the square roots are the same, you multiply them together, they just cancel each other out. So that leaves us 3x plus 3h plus 2 minus, and then we'll put a parentheses because this minus has to affect everything to the right. Now square root of 3x plus 2 times square root of 3x plus 2 is 3x plus 2 all over our denominator. So h times square root of 3x plus 3h plus 2 plus square root of 3x plus 2. Now up on top, a negative out in front of your parentheses flips the sign of everything inside, so that's going to flip the sign of the 3x and of the 2. So we got limit as h goes to 0 of 3x plus 3h plus 2 minus 3x minus 2 all over h times square root of 3x plus 3h plus 2 plus square root of 3x plus 2. Want to combine together like terms. Here we have 3x minus 3x. Those are going to cancel. Here we got 2 minus 2. Those are going to cancel. So we got limit as h goes to 0 of 3h over h times square root of 3x plus 3h plus 2 plus square root of 3x plus 2. Well, up on top we got 3 times h, and down below we got h times something. Since both of those are multiplication, the h's cancel. And that h is what we're really wanting to get rid of. So we got limit as h goes to 0 of 3 over the square root of 3x plus 3h plus 2 plus square root of 3x plus 2. Well, now we're ready to plug 0 in for h. So this gives us 3 over square root of 3x plus 3 times 0 plus 2 plus square root of 3x plus 2. 3 times 0 is 0, so that drops away. And we got 3 over the square root of 3x plus 2 plus square root of 3x plus 2. Now, since those radicals are the same down in the denominator, we can add them together, in which case we'd add numbers in front of them. There's invisible 1 here, invisible 1 here. So this would be 3 over 2 square root of 3x plus 2. And that would be our answer.